spring light falls into winter night.
Welcome to Mixed Expressions in Complex Fractions. What a title, right? And believe me, it will live up to its name. This is where we really get to have more fun than you could possibly imagine. Let's first take a look at mixed numbers. Remember way back when, mixed numbers, there is a whole number component and a fractional component. They could have been negative. I could have had -4 and 2/7. Anything like that would be a mixed number. And remember, you used to use the shortcut, multiply 5 by 3, add 1 to get the improper fraction. So that would have been 16/3. Now the actual process behind that was, if we think about it, we have an integer and we're adding an integer to a fraction. We're going to write the integer with a denominator of 1. Then we're going to go ahead and add the two fractions. So this would have been 5/1. We're adding 5/1 to 1/3. And to do that, we have to multiply the numerator and denominator of this fraction by the common denominator of 3. And so that's where we got the multiply 5 by 3 and then add 1 from. It's just a shortcut. So this would have been 15/3 plus 1/3, which is in fact 16/3. It's a long process for our shortcut. However, we need to keep that in mind when we're adding mixed expressions that involve variables. Let's take the first one, for example. I want to add this y/1 to the 5/y. So I have to get a common denominator, meaning I'll have to multiply this entire fraction by y/y. When I do that, I get y² over y plus 5/y, which is just y² plus 5 over y. Not so bad, right? Don't know what I was thinking. So now the next one, I'm going to put the whole expression x plus 1 over 1, and to get a common denominator, you got it, I got to multiply by x minus 1 over x minus 1, these two fractions together. So what is that going to give me? Well, it's going to give me x² minus 1, and I just used our little cheat for the difference of two perfect squares over x minus 1 minus 1 over x minus 1. So that's x² minus 2 over x minus 1. As you can see, these can get very complicated as we move along. Why don't you try 3 and 4 and come back and check your answers. Okay, so 3 and 4 are shown there. If you have any issues with those, make a note or try them again and then make a note, and we'll go over them tomorrow. I'm going to move on to complex fractions. Complex fractions are fractions with one or more fractions in the numerator or denominator. Fractions that have one or more fractions in the numerator or denominator. Remember that initially when we started doing different types of simplifying monomials, I said you cannot have a complex fraction as your final answer. Complex fractions can and must be simplified. Simple fractions are fractions with no fractions in the numerator or the denominator. So complex fractions involving variables should be simplified. The steps, as you can see, are to change the denominator or numerator to a single fraction, and step 2, replace the fraction bar with the division symbol to divide as usual. So if we look at the example shown, what we've done here is we've kind of left the numerator alone. The x² minus 9 pretty much stays in its position because that's not complex at this moment. Then this part of it is complex, and we have to add those two fractions. So to do that, we need to get a common denominator, multiply both of these by x, multiply both of those by 3, and I get x over 3x minus 3 over 3x. So that works out to be x minus 3 over 3x. Then I change flip. So I'm going to go x² minus 9 over 1 times 3x over x minus 3. And as you can see, that has to be simplified. And the final answer, once you multiply that out, would be 3x² plus 9x, or 3x parentheses x plus 3. Let's try an example. Looking at number 1. They both have fractions in their respective numerators and denominators. So what I need to do here is I need to change that 1. This is pretty easy actually, because we know 1 is x over x, and I know that x², making a common denominator, is x² over x². That's going to give me x plus 1 over x in my numerator, and x² minus 1 over x squared in the denominator. Now remember, this is a division bar. So I'm going to keep the x plus 1 over x. I'm going to change my division bar to a multiplication, and I'm going to flip this fraction. This is just division like we did a couple days ago. It's going to be x squared over x squared minus 1. And at this point you should know what to do. Why don't you go ahead and quickly pause, multiply it out, and tell me what you get. When I do all the simplifying, I get x over x minus 1. So if you think about it, this nasty mess that was there to begin with simplifies to this. Why don't you try number 2 here if you can and come back and check. I'm going to work through it, so if you get stumped, you can go ahead and pull the video back up. I need a common denominator. All I have to do is multiply the first fraction by 7 over 7. So it's going to be 7x over 7, and this is going to be 7x over 7 also. Now remember, we can't cancel those. Those are groups. In the numerator, I'm going to get 7x plus 5 over 7 all over 7x minus 2 over 7. And I'm going to remember that this is saying divide. So I'm going to keep 7x plus 5 over 7, change and flip, and then it works out pretty nicely. I can just cancel these 7's, and my final answer is 7x plus 5 over 7x minus 2. Not too bad, right? Number 3, do you want to try that one on your own? And you should pause here and try this on your own, because that's how you're going to know where you need help. What I need to do is get a common denominator, so I know that's 5 over 5, and I know that's 25 over 25. The ones are pretty easy because you just make it over itself, right? So this is x minus 5 over 5 all over x squared minus 25 over 25. Remembering this just says division, I'm going to keep, change, flip. So x minus 5 over 5 times 25 over x squared minus 25. And that should look pretty easy to you at this point. Go ahead, solve that part on your own. And the final answer is 5 over x plus 5. Okay, are we having fun yet? We will, promise. See y'all tomorrow.